Hi guys, this is Mrs. Gassler, and in this video we're going to talk about some periodic trends. There's 3 of them that we're going to talk about. So we're going to use some Cornell paper, and you're also going to need one of these handy small periodic tables with some periodic trends on the back. And let's go ahead and get started. So you're going to need your name, class period, and date right here. And we have an essential question that we're looking at, which is how does atomic size, electronegativity, and ionization energy change as you move around the periodic table? We're going to look at each one of those individually here and talk about why they are. And we're going to start with atomic size because the others are related to that. So when we say atomic size, we mean literally the size of the atom. Sometimes people talk about the radius of the atom from the nucleus to the last electrons, and they all mean the same thing. The bigger the radius, the bigger the size, the smaller the radius, the smaller the size, so it's all the same thing. So when we look at the trends, first we're going to look at going down the periodic table. A group is the fancy name for a column, which I think only has one L in the periodic table. So those groups in the periodic table, group is what we call that. The groups are a column. When we group them together, this is what we see. First off, as you go down the group, the atoms gain an energy level. They gain an energy level. We saw that with the SP, or the electron configuration. We looked at how they go down the energy level there. And when you end up with more energy levels, that means you have a bigger atom. We're literally adding them on, so let me draw that right here. So here's one energy level. If I add another energy level, oh look, it's bigger. This one's obvious, right? Oh look, it's bigger. So we continue to make it bigger as we add more energy levels. So when you move across a periodic table, something a little bit different happens, and this is the one that's difficult to think about, but we'll make it easier, okay? So as you move across the periodic table, atoms gain 1 proton. For every box you move over, it's 1 proton and 1 electron. So they're gaining both protons and electrons. And if you take physics 2, you can find out all about what that means as far as forces within the atom. But there are electric forces that are getting bigger. And when you have more protons and more electrons, you have more pull. Like I just said, the pull gets stronger. So that pull is getting stronger. When you have more pull, that means that you're kind of literally pulling stuff in. So this is a smaller atom. So if I were to draw that, I have the same number of energy levels, but they're getting closer together. The more electrons I have in them, the more they get pulled toward the middle. So they're getting smaller as I move across because they're getting pulled in. Like adding more rubber bands, they get pulled closer together. Okay, so we're going to draw that on the small periodic table. That's going to be this number 7 here, the atomic size. So as I go this way, they're going to get smaller. They're getting pulled in as I move across, and as I go this way, they're getting bigger, which I forgot to mention. We call that a period. Those rows are called periods, and I think period, group, period, group, okay? So our biggest atom is going to be over here. This is where our biggest atom is. And our smallest atom is going to be over here. This is our smallest atom. And so I'm going to draw a nice arrow here that kind of gets bigger, because this is the direction of increasing size, okay? So that's atomic size right there. So the next one we're going to talk about is electronegativity. Now, electronegativity is the tendency of an atom to attract electrons. So let's pretend there's some electrons out there. How likely is an atom to attract more? Now it's related to the size, so conveniently I have that right here. So if we have a smaller atom, the reason those are going to have an easier time attracting electrons because that positive nucleus is closer. Also something you can learn in physics too. It's closer. And the closer those electrons are, the easier it is for them to pull on each other. So closer means they're going to pull harder. So it'll be easier for those electrons to get stuck. They can get closer to that nucleus. Just like if you had a magnet, if you get closer, it can pick up a paper clip. Okay. Now bigger atoms have a harder time for the opposite reason, attracting electrons because their electrons, that positive nucleus, is farther. Farther means there's less force, so they can't pull quite as hard. So when we draw that on the periodic table, so the bigger atoms, that's going to be right here, electronegativity. Okay, so remember, our biggest atom is here and our smallest atom is here. Our biggest atom has a harder time. That means it's going to have a lower electronegativity. So this is low down here. And then our smallest atom is going to have an easier time, so that's going to be our high electronegativity. In fact, this group over here, we don't really count. They don't care about extra electrons, and we'll talk about why later on. So low and high. So this arrow is going to kind of be the opposite of our last one. This is increasing in the other direction. So I'm going to draw my arrow like that. Increasing is this way. So these are our high electronegativity, and these are our low. Okay, one last periodic trend, and that is ionization energy. And ionization energy is the amount of energy needed to, whoops, I ran out of room, remove an electron. So we've got these atoms here. We're going to just pluck an electron. How hard is it going to be? Now this is also related to the size. Just like electronegativity, it's related to the size. Now if we're talking about our smaller atoms hold on to the electrons more tightly because they are closer to the nucleus. We'll put that here, closer to nucleus. Means they're tighter. And when they're tighter, that means that it is harder to remove them, because there's more force. It's like a stronger glue there, harder to remove. And if it's harder to remove, that means we have to use more force, which means we have to use more energy is needed. So the ionization energy gets higher with those smaller atoms. Now the bigger atoms, they kind of do the opposite. They hold more loosely, I think that's a word, because they're farther from the nucleus. They don't have as tight of a glue, farther from nucleus. And so they are looser, which I don't think is really a word, but when they're looser, that means that means that it's easier to remove those electrons. And when it's easier to remove those electrons, that means it takes less energy to do it. It's not as hard, so you just pull a little bit and those electrons come right off. So when we look at the periodic table, the ionization energy is going to have the same pattern as electronegativity. It doesn't take much energy to remove these electrons, so I'm going to write easy. And it takes a lot of energy to remove these electrons, so it's hard to remove those electrons. So we're going to need more energy over there. So this is what my arrow is going to look like with my increasing energy over there. All right, so if you have any questions about periodic trends, make sure you ask your teacher. Thanks for watching.